The intention of the Volkswitch 3D Symbol Remix Designer is to give you a way to modify and extend the concepts originated by Project Core. Fundamental to the designer is the decoupling of characteristics of a 3D vocabulary symbol to allow you to construct a symbol set that is appropriate for your clients and their specific therapy. When you look at the Openscad user interface running the symbol designer, you will see the image of a default symbol on the left. On the right, you see a set of expandable sections that you can use to modify the default symbol. There are 5 sections to help you modify the 5 basic characteristics of the symbol: its shape, edge texture, graphic, engraved text, and hole location. Each of these basic characteristics is independent of the others. You can change one characteristic without that change limiting your choices elsewhere. Above the expandable sections on the right, there's a box where you can choose and save presets. A preset is a collection of settings for a symbol that you have saved with its own name. I recommend that you start at the top of the expandable sections and work your way downward. Let's look at the symbol shape section first. The first option is symbol shape. The current value is triangle, with the word verb in asterisks. As the text above the pull-down box says, the Project Core word class is what's between the asterisks. So if you want to stick with the Project Core standard, you would associate a triangle-shaped symbol only with verbs. But the designer doesn't place that limitation on you. You can organize your core or initial vocabulary any way you want, and assign your symbol shapes in any way you want. Expanding the pull-down shows that you have 6 shapes to choose from. I'll choose each one in turn to show you what each one looks like. The displayed symbol will change every time you change the value of an option. Let's see what happens when you change the width and depth of the symbol. The chamfer refers to this small angle cut around the top and bottom edges of the symbol. It helps make the symbol more appealing to handle, but you can remove the chamfer by choosing No. The last option in this section is Symbol Display Color. As the name implies, this option only controls the color in which the symbol on the left is displayed. The final color of the symbol depends entirely on the color of the filament that you load into your printer. As with symbol shape, Project Core has a standard for the color of each word class, but you may want to use color in a different way. Project Core specifies that red should only be used for verbs. You may want your verbs to be green, as specified in the Fitzgerald key. Again, what really matters is what color filament you have loaded into your printer when you print the symbol. The displayed color is just to help you better envision your symbol, and as a reminder regarding what color filament to use when you print it. Now let's look at the options for edge textures. There are 6 possible edge textures, just like there are 6 possible symbol shapes. But you can mix and match them however you'd like. Let's look at each of the edge textures. Bumps, smooth sides, horizontal grooves, cross hatches, and vertical grooves. Project Core specifies a particular edge texture for each of the word classes, and that relationship is indicated between asterisks. There's nothing else to specify in this section, so we'll move on to the symbol graphics section. This is the most complex section of the symbol designer. Before we look at the various options, let's look at how graphic files are handled by the designer. This is what the folder looks like that contains the Symbol Designer program. The file that ends in SCAD is the designer program. The file that ends in JSON holds the definitions of some predefined symbols. There are also two folders that contain graphics files. First, we'll look at the contents of the folder Project Core Graphics. It's made up of pairs of files. One file is a PNG file, and the second is an SVG file. I took the images of the PNG files from a PDF copy of the Project Core communication board. The images are intended for use by visually impaired and sighted individuals, but we thought the image outlines could be useful to blind individuals as well. The SVG file contains a black and white version of the image that can be read by the symbol designer. By the way, we've already created symbol definitions for you for all of the Project Core symbols. They're accessed by going to the presets region of the designer. If you want to create a symbol representing the concept all that is very similar to the Project Core symbol, you just select PC All from the presets pull-down. The designer will warn you that you may be throwing away some changes that you've made, but that's okay. If that's all you want to do, you can just render and export this design as an STL file. Note that there's nothing in the STL file that says that the symbol should be blue with a white graphic. You'll need to handle that during the slicing and printing process. Let's look at what's involved in creating a new symbol with new graphics. Specifically, let's create a symbol for the concept to hit. The My Graphics folder is where you store images that you will use to extend the original core symbols or substitute for a particular core symbol. Initially, it contains only two files, an image of a butterfly and its associated SVG file. I'm going to insert a couple more files. These files will be used to create a symbol representing the verb to hit. The process for taking a graphic file from the web, as I did, and creating an SVG version from it is in another video. Note that the name of the SVG file is hit. Let's go back to the symbol shape section and select a triangle for the shape. I'll leave the width, depth, and chamfer as they are, and we'll choose red as the symbol color. In the edge texture section, I'll set the edge texture to vertical ridges. In the symbol graphics section, I'll set Use Project Core Graphic to No. The designer then ignores the value of Project Core Graphic name, and we can assign a value to My Graphic name instead. We'll type in the name of the SVG file that we want to use for our graphic. In this case, hit. The designer can read the contents of the SVG file, but it doesn't know anything about the aspect ratio of the image. Aspect ratio is the relationship of the height of the image to its width. Windows doesn't know enough about SVG files to tell us the height and width of the image, but it does know how to report that for PNG and JPEG files. I'll right-click on the PNG file and select Properties from the pop-up menu. On the Details tab, I see that the width of the image is 255 pixels and the height is also 255 pixels. To calculate the aspect ratio for an image, I divide the height by the width and then multiply by 100 because the designer needs a value that's an integer. 225 divided by 225 is 1, and 1 times 100 is 100. So I'll set the aspect ratio to 100. Now I need to resize the graphic and move it around horizontally and vertically on the face of the symbol until it fits and is as large as possible. I'll just keep changing the values of the three options until I get what I want. It can help to view the symbol from above. That's this button here. It also helps to use a contrasting color for the graphic. In this case, I've chosen white. As with the symbol color, I've just set the display color for the graphic. How the graphic appears in the physical 3D printed symbol depends on the colors of filament that you have and whether you can interrupt your print and change the color of the filament when you start printing the graphic. I'll return the display to its original orientation by pressing this button. That way I can see how far the graphic rises from the surface of the symbol. Right now the graphic rises 1 millimeter from the surface. I can increase that amount by changing the value of graphic height. You have a lot of freedom, though the optimal height will depend on what works best with your client. Also note that thin elements of the graphic may snap off if they are too tall. Let's move next to the symbol text category. If you want, the designer will engrave the name of your symbol on the underside. I'll flip the symbol over by clicking and dragging with the left mouse button. The first thing I'm going to do is move the text down so I can see it better. I can reduce and increase the size of the text by changing the text height. If I do, I'll probably need to adjust the horizontal and vertical location of the text so that it fits nicely. I can also change the font style from regular to bold. I can hide the text altogether by setting the value of engraved text to no. Let's go back to the standard orientation and finish the design of our symbol by choosing whether and where to put a hole. You can hang this symbol on a string by putting a hole through it. The hole can go from side to side at the top of the symbol as it does right now. That makes sense if the symbol will hang from a peg on the wall. You can put the hole at the bottom of the symbol instead, but still from side to side. This makes the most sense when putting the symbol on a string that will hang from the client's neck. That way, when they raise the symbol, it's properly oriented. You can orient the hole so that it goes through the symbol from front to back. You may need to decrease the diameter of the hole so that it fits within the boundaries of the symbol and doesn't interfere with the graphic on the symbol. You don't have to put a hole through the symbol at all. You may want to put Velcro on the back of the symbol and attach this and other symbols to a felt sheet. Just set Add a Hole for String to No. When you're satisfied with your design, you can save it for future use by adding a new preset. press the plus button and give your new preset a name. If you're ready to print the symbol, choose Design, Render. Then choose File, Export, Export as STL. If you'll be printing the symbol yourself, go ahead and load the STL file into your slicer software. Look at the thin part of the image that looks like an arrowhead. It's probably trying to indicate the direction of the hit. Let's see what happens to it when the model is sliced. In this case, the arrowhead is a single thread of filament wide, about 8 threads high. This part of the graphic is probably going to snap off the first time someone presses on it. Some graphic elements will disappear entirely after the model is sliced because they're too thin to be printed. This will be a particular problem if you're designing small symbols and graphics with lots of detail. You can try to go back and resize your graphic, or you can just sacrifice that piece if you think it's not critical.